Hi everyone! So today we're going to talk about surface area of complex polyhedrons. Now, you guys did an okay job on rectangular prisms, but I do want to review just one quick example of that. And we're also going to move on to square pyramid. I think visualizing the nets of these kinds of shapes will work much better to helping you understand them. So our objectives for today are we're going to break down the polyhedrons, which are our 3D shapes, into polygons, which are 2D shapes. And basically what we're doing is we're going to smush the polyhedrons down into their basic format or into a shape that we can see all of the sides at one time. That'll help you to visualize what areas you need to solve for in order to find the total surface area of a three-dimensional figure. So I've got a couple formulas here: a rectangular area, the area of a circle, and the area of a triangle. I think today we spent sufficient time on the area of a triangle being 1/2 times the base times the height. But what I'm not sure if you really understood was that when you have base times height, you are basically finding the area of a rectangle, right? Rectangle area is length times width, or width times height, as it says in that formula above. Area of a triangle is base times height, but it's 1/2 of that area. So what I just wanted to demonstrate was that if you insert a triangle into the inside of a rectangle, that particular shape, will take up about half of the area of the rectangle. And we can actually prove this. This is true. So if I go ahead and I fill in the area of my rectangle that's not used in the triangle, fill in that shape. And on the other side as well, I can fill in that area. And I can reposition that area to the inside of my triangle, now showing that that area takes up the same amount of space. Approximately, it proves to me that 1/2 of the area of a rectangle, which is built around a triangle, will be the area of the triangle. And you can see that because the height of the triangle is equal to this vertical height that they give you as a reference point. So you are really looking at 1/2 of a rectangle to be equal to the area of your triangle. And I just wanted to make sure you guys made that connection. So let's take a minute and look at the interactive model of the 3D pyramid, or a square pyramid. And hopefully this gives you a better understanding of what kind of surfaces the pyramid has, that we're going to have to find the sum of the area of the surfaces to find the surface area. So as you can see, the pyramid is folding and unfolding in that right hand animation. And when it's open, it looks as though it's made of one square and 4 identical equilateral triangles. And that's important because we have the formula for the area of a square in addition to the formula for the area of a triangle. So now that we know the components of a square pyramid in terms of what kind of shapes it has on its surfaces, we can find the surface area of the entire polyhedron. So the base of my square pyramid is a square, and given to me in this example is that the side of the square base is 11 yards. Well, the area of the base is going to be 11 times 11, which is equal to 121 yards squared. And that's because I know my area formula for a square is length times width, or base times height. When I look at this triangular sides of the square pyramid, area of a triangle is equal to 1/2 times the base, which is given as 11, times the height, which is given as 9. Once I do my multiplication, I get 11 times 9, and that equals 99. 1/2 of 99 gives me 49.5. Again, this is yards squared. Knowing that I have 4 triangles that make up the lateral sides of my polyhedron, I need to multiply 49.5 times 4. And 5 times 4 is 20. I carry my 2. 4 times 9 is 38 plus my 2. 4 times 4 is 16 plus my 3. So the area of the lateral sides of my polyhedron or my square pyramid is 198 plus my 121 yards squared that exist from the square base of my pyramid. My total surface area is going to equal 319 yards squared.